Hello guys, in this video we'll talk about singleton design pattern. Before moving further, let me give you a quick outline of the content. Firstly, we're gonna talk about design pattern in brief. Then we'll try to understand what is singleton design pattern, how it is implemented along with the code and an example, and how it is different from prototype design pattern. After that, we'll see all the ways to instantiate a singleton object and the effect of reflection and serialization on a singleton. Lastly, we'll see how to overcome these scenarios. So what are design pattern? Design pattern are well-proven solution for solving specific problem or task. They are already developed pluggable solution which your developer can use in their code, and it help improve the performance while reducing the chances of bug. There are three type of design pattern. Firstly, the creational design pattern that is concerned with the way how you create your object. Secondly, the structural design pattern that help you compose an object efficiently. Thirdly, the behavioral design pattern that is concerned with the communication between the object, how efficiently they communicate with each other. So moving on to singleton design pattern, it's a creational design pattern. It says that define a class that has only one instance and provide a global access to that instance. If we talk about the definition, it is a design pattern that restricts the instantiation of a class to one object. That means only one instance of the class is created throughout the life cycle of the application, and the same instance is accessed in whole application through that global access point. If we have a look at the structure of the singleton class, it contains an read-only instance to the singleton class and a common global access point to the instance along with other methods if required. So let's understand this with a simple example of a printer. There are many processes running in the operating system trying to print something. As there is only one printer, there is a single instance in the operating system that can be used to print. Now suppose Sublime Text want to print something. It will request for the instance and send the print request through it. The request will be executed on the same printer instance. Now suppose another application want to print something. It will make a request for the printer instance and send a print request through it. That request will also be executed on the same printer instance. So in this case, only one instance is created and all the processes are using the same instance for their job. So let's understand the difference between singleton and prototype design pattern. Singleton design pattern create a single instance throughout the application and provide access to it, while the prototype design pattern create a new instance per request by cloning from an existing object, which can be customized as per the requirement. So let us see how to create a singleton design. In order to create a singleton design, we require firstly a static reference to the object, which will hold the single copy of object in the class. After that, we need to make the constructor private so that it can't be instantiated outside the class. And thirdly, we need a static factory method. This provides the global access to the singleton object and return the instance of the object to the caller. Here is the code snippet for the same. Please note, this is eager instantiation strategy. During object creation in singleton, we can follow either eager or lazy instantiation strategy. Early instantiation means creating object at loading time, and lazy instantiation means creating object whenever required. If we are following eager instantiation, we create the instance of the class at the time of declaration of the static data member. So the instance of the class is created at the time of class loading itself. Here is the code for the same. Now if we follow the lazy instantiation strategy, we create the instance of the class in synchronized method or synchronized block so that the class instance is created whenever it is required. Below is the code for the same. The advantage in lazy instantiation is that if the object is not required throughout the cycle of the application, the object is not created and hence memory efficient. So now we will talk about all the ways to instantiate singleton object and the effect of reflection and serialization on singleton. Firstly, there is eager initialization. In this, we are creating the object of the singleton class with declaration itself. So the object will be created during the class loading itself and will stay in the memory. Next, there is the static block initialization, which is very similar to eager initialization. In this, we are using a static block to initialize our object. As you know, the static block run during the class loading itself, so the object is created during the class loading itself. Next, we have lazy initialization. As you can see, the object is created in the get instance method itself. So whenever the first call to the get instance method is made, the object will be created. But this can cause some problem in multi-threaded environment, as more than one thread can go for the null check at the same time and will find that in instance is null. So both the thread will try to create a singleton object, and hence more than one object of the class will be created. In order to overcome this problem, we can make our code thread safe. So we can either use a synchronized method. We can make our get instance method as synchronized and do the following code in there. The downside of this will be our get instance method will be synchronized and only one thread will be allowed in the method at a time. This will slow the code down. To improve the efficiency and keep the code thread safe, we can use a synchronized block instead of synchronized method. And we need to add an extra overhead by double checking the locking principle in order to improve the efficiency here. The double null check will be required by multiple thread in order to make sure that they are not entering the synchronized block uselessly. There is yet another way to instantiate a singleton object, and that is by using static inner helper class. So below example you can see we have created a static inner helper class that create the object of our singleton class for us, and this object can be then used through the global access point. Now let's see the effect of reflection on the singleton pattern. As you know, we can use reflection to change the access of any method or any variable in our code. So here we have used the reflection to change the accessibility of our constructor of singleton class to access it outside the class. And then we are using that constructor to create the new instance of the singleton object. And hence more than one singleton object will be created. So we can break our singleton pattern using reflection. Now in order to prevent this from happening, we can use enum in Java. Here is an example of the same. We have created an enum with an instance and made some functionality for the same. The enum will have only one instance and that will be served to all the requests that are being made. And this is an effective singleton implementation. Now if we talk about serialization of singleton object, we know that when we try to deserialize a new object is created and the properties are set from the stored state. This can now break our singleton design pattern. So to prevent this, we have overridden our read resolve method in the singleton class. This method will return the existing instance instead of creating a new object, and the properties will set to the existing object itself. So this is all about the singleton design pattern. Hope you understood it well. For any query, let's hear it in the comment section.